examples. But I think the first few examples are simple. So just start with example 4 onwards, and then example 5 and 6. When we discussed it in class, there were some issues, but I think I may have managed to resolve them or at least explain as to why they're happening. So let's start with example 3. So this example 4. What this example does is it performs adaptive thresholding. So it takes the ship image and does adaptive thresholding using two different methods: adaptive mean thresholding and adaptive Gaussian thresholding. So I think this is just a click of a button. There isn't really much to this example. So if you run this, it gets executed, and then if you go to your output directory, you should be able to see the two images. So let me quickly show you. So these are the images that were just created. So the custom threshold. No, sorry, the Gaussian threshold and the mean threshold. So these are the two ones. So the mean threshold, this is the one that was just generated. So you can see this is, okay, I don't think you can see this. I have to share my screen. So this is the mean threshold image. So this is the image that you get after mean thresholding. And then let me open the next image, which is the Gaussian threshold image. So this is the one that you get after Gaussian thresholding. So which one is better? Yeah, it really depends on the application. In this case, they seem similar, but again, with different applications, they might actually be different. Okay. So there is this example is rather simple. There isn't really anything too complicated about it. So let me just go back to Spider. And I want to move to example 5. Now with example 5, if you run this as is, let's go ahead and quickly run example 5. Let's run it one more time. So with this, what you see is there isn't much of a gain in speed when you add more processes. So this code basically takes pretty much the same amount of time, regardless of whether you're using one process or two processes or three processes. In fact, when you actually use 4 processes or 6 processes rather, your runtime increases instead of decreasing. In fact, you can see at this point around 4 cores, your runtime actually starts to go up. Now, why is this happening? This is different from the book. I mean, if you look at the book, the sort of output that you see is like this. With example 5, you have like about 0.6 seconds and then 0.3 seconds, and then after 2 processes or 2 cores, it kind of remains constant and does not go down further. Now, why is this happening? I'm not sure if I can explain why ours is taking more time. I think this output really depends on the way it can. So the output of this example can vary based on um, what system you're using. It can also vary on your clock speed, and it can also vary on, I guess based on how much load is present on your system. And uh, so this is a little difficult to predict. I mean, you can try running this example, and it may actually be different in your case. But so last night when I ran this, I actually it took me a lot less time than what I'm getting right now. Um, but one thing that kind of remains constant is that I don't really see any improvement in performance when I actually add more processes into the system, right? Now, in order for this example to run, you need to have OpenCV installed. You will find some instructions in the book about how to install OpenCV, but I think those instructions may be a little bit outdated. So the way that I installed OpenCV was installed it just through pip, and you can basically find the instructions for installation on Google. So just Google the installation instructions, how to install OpenCV, and it will basically tell you how to do it. Um, so let me go to example 6. Now with example 6, what you should be getting is um, what they actually did was they basically uh, put this image reading part inside this function that gets executed in a process. So the processes do not have to wait for 400 images to get read and then start working. Each process basically does the reading on its own. So this is something which gives you a little bit of a speed bump, and it should kind of give you a little bit of an increase in performance um, when it kind of comes to using more cores. So if we run this example, okay, so there's one change I made to this. So let me stop this for a second. So it should run the first one at least. Let me comment this part out. Okay, so let me run this again. So in this case, you do see a little bit of a boost in speed. So you see that as compared to a single core, once you go to 3 or 4 cores, you do see some sort of increase in speed, but it's not that significant. Now, there's nothing really wrong with the code or the idea behind the code. I think what is happening here is is that the process is too simple. So on my system, at least when I try to read the images and do thresholding, it doesn't really take a lot of time. So I don't really get any advantage from putting this simple task inside different processes. And the reason for that is that because, just even if I was doing it with a single process, it takes a very small amount of time. So I mean, I could try to run multiple processes, but the overhead that I get by invoking multiple processes, um, that is greater than the amount of gain in time that I would get um, by um, by automating these things or by introducing uh, multi-processing. So uh, But in real life, if you're kind of doing something where you're kind of running stuff in parallel, and each of uh, these things that you're running, so each of these processes that you're running for doing some image processing task. Now, if that task actually takes a good bit of time, then introducing multi-processing actually will help you. So in this case, if you, what I did last night was made a little bit of a change. So if you import time and then you introduce a little bit of a delay artificially. So in this case, I introduced a delay of 0.05 seconds. So it's about 50 milliseconds delay that I'm introducing. Um, then what you actually will see is that when you actually introduce um, other processes into the mix, you will actually observe gains in speed. So if I artificially make this slow, it will actually show you um, that um, that you do get a gain in speed when you actually add more cores to the mix. So let's run this now. So with this, I'm going to read 400 images. And I'm also kind of introducing this delay of 0.05 seconds after reading every image. So the first one, when I'm using just uh, one uh, one core. So I have 400 images, and when I'm reading each image, I'm introducing this delay of 0.05 seconds. So the first one should execute in about 20 seconds. You can see this guy executes in about 25 seconds, so a little, about 5 seconds more than what I expected, but it's close to it. But now notice, take a look at this. When I introduce two processes, my time almost halves, right? So if I was taking like 25 seconds initially, now I'm taking about 13 seconds. And then with three cores, I'm taking about 9 seconds. And you can see with four processes, I'm taking about 7 seconds. With five, I'm taking 5 seconds. And then um, six, I'm taking about 4 point something seconds. So you can see when I went from one process to six processes, the runtime that I had, so if this was 24 and this was 5, I had this reduction of about 6 times in the amount of time that it took my code to run, right? So previously, when I ran this without the delay, uh, this process was so quick that adding extra cores just introduced overhead, but it didn't really um, give me much improvement in speed, because there is a slight bit of an overhead by introducing each a new process, because you have to create a process, you have to manage a process, and so that kind of adds that overhead, right? Uh, and so that overhead, even though you may have obtained some gains in speed in terms of everything else, but the overhead kind of uh, is much larger than the sort of gains that you were getting um, by introducing a new process. But in this case, you have the same number of processes, but this is just to kind of demonstrate that, if you were doing some image processing operation which actually consumed a decent amount of time, in that case, introducing multi-processing would actually um, would help you, right? And you can see it in this case, and here you can see that because these are more or less independent tasks, so introducing a new process every time kind of reduces your time by the number of processes that you have introduced. So if you double the number of processes, your time kind of went down by half, right? So it went from 25 to 13, so almost half. And then when you go from 2 to 4, you can see that um, this reduces from 13 to 7, so it's almost half, not exactly half, but almost half. So this is interesting, right? Um, so uh, so I would suggest that in the rest of the lab, maybe go through these codes first. If you have not been able to install OpenCV, maybe install OpenCV, and then play around with example 6 and 7. read the documentation of some of the functions, try to figure out why we're using map in example 6 and star map method in example 5. Maybe you can find some documentation about this. I also included this in the notes, and you'll find it there too. But on Google also, if you try to search for a process.starmap and process.map, it'll tell you the difference between the two. Um, and so, just try to understand this code overall. And in the meantime, what I'll do is I will make the questions for the lab quiz, and then I'll share those before the end of the lab with you, hopefully. And I'll also try to maybe make assignment 3 as well, that you can then use uh, as your final assignment. Okay? All right. Are there any questions? Okay, so just one more thing. If you're going to run these examples, so go through these examples, Shashank. First, make sure you have OpenCV installed. Also, I don't think I'm going to share. Well, let me see how big this is. But if you go to chapter 8 and then just run the codes from this directory, because the code or the examples that you have here basically require that you have these files in these folders. So you have this folder input slash large input, output slash large output. So it kind of the program requires this directory structure. So expects that you have this these images here, uh, which are kind of available over here. So that's what I want you to do. So, go to my mastering concurrency in Python and then go to the directory for chapter 8, and there you'll have these examples already. And you'll also have the images that you need. So you will have the ship image that you need to do the thresholding and converting things to grayscale and all that stuff. So that's already there for you. So um, run these different examples, but mainly focus on examples 5 and 6. You may also want to do example 7 as well. It's a simple example. It's not complicated to run. I mean, as long as you have all the data in the right place, you should be able to run example 7 as well. Slightly different from example 5 and 6, but um, uh, can't you just download this from GitHub? I mean, you can download the repository from GitHub. So if you actually go to the GitHub link for the book, let me share that uh, with you. Um, so if you go to this GitHub of the, yeah. So just go to the GitHub for this, uh, and then if you've downloaded it from there, you should already have it. So go to chapter 8, and you should have all these files here, right? Uh, Over here and here as well. So everything is basically there. So just download it from there. Um, so if you basically go here, and you should have a link for download the whole code. So just download this whole code and then unzip it, and you should get everything uh, in the structure that you have online. Okay. Um, yeah, let me send you the link. Okay, so there's the link. Again, when you go to the link, just click on this green button for the code and then download zip. And once you download zip, you will be able to download the entire code for the all examples in the book. And then just unzip this and then go to chapter 8 and then take a look at these examples. Examples 5, 6, and 7. Play around with these and try to understand what they're doing. Okay. Yeah. All right. So I'm going to start working on the lab quiz. So that will be based on your understanding of these examples. So make sure you go through them so then you're able to do the lab quiz. Okay.